Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ismail. My metric number is MA18276. So now I want to explain about the abstract. In this experiment, friction flow in pipes, we are going to calculate the head loss that occurs due to the flow of the fluid through pipe lines. Overall head loss in a pipe is affected by several factors, which consist of the size of the internal pipe diameter, the viscosity resistance of the fluid, and the internal roughness of the inner surface of the pipe. We also going to use four types of pipes, which are straight pipe, elbow pipes, bend pipe, and 45-degree angle pipe. With considering Darcy respect, friction factor, velocity of flow in pipe, diameter of pipe, and length of pipe, we will gain the result of head loss that due to the friction in those pipes. Next. For the background, continuity equation is a principle of conservation of mass in terms of mathematical expression in a controller value which has a single inlet and a single outlet. Principle of conservation of mass state for a steady state flow, mass flow rate into is equal to the mass flow rate out. Neutron fluid is a fluid with viscous stresses from its flow which are linearly correlated to the local strain rate at every point. Next, for the problem statement, water supply in residential area is from the main water tank. It is quite a long distance from the main water tank to the house's water tank. The pipes need to be a very efficient state in terms of angle to flow the water in a short time. Thus, we need to calculate the losses, velocities, and pressure in pipes at a certain angle, which is straight, elbow pipe 90 degree, bend pipe 90 degree, and 45 degree. Next, for our objective is to determine the major and minor losses with the fluid flow in different piping systems. Second, to evaluate the value of velocity for different diameters of the pipe. Third, to apply the concept of Bernoulli equation in finding the major and minor losses correctly. Thank you.
Assalamualaikum everyone. So I'm the second presenter, Shazani bin Muhammad Sunusi, MA1883. So let's proceed to chapter 2, the theory. The productivity of the pipeline should be increased. In example, if the flow rate increase, the head loss per unit length decrease. Next, doubling the pipe's diameter can be significantly reduced, a relatively low capital cost to overcome the frictional resistance in a rough transporting a certain flow rate. So this is the formula. H loss equals to total head major losses plus total head minor losses. And next is major head loss are defined as loss of energy due to the resistance of the friction. So this is the formula. Head loss major equals to F L over D times V square over 2G, where F is frictional factor, L is the line of the pipe, D is the diameter of the pipe, V is the average speed of the pipe, and G is the gravitational acceleration. Okay, let's proceed to chapter 3. Method and procedure. So this is the apparatus. Number 1 is fluid friction apparatus. Number 2 is hydraulic bench, as shown. And number 3 is pressure sensor. And number 4 is data measurement and data acquisition. The next is procedure. First, by turning the valve tab to the left, all the fluid friction device valve is open. When all of the valves are turned on, power supply and the pump can be switched on. Second, control valve is used and water volume adjustment adjusted. Then the unused valve will be closed for the first experiment, that is the straight pipe. Third, following that, a pressure measurement inside the pipe was connected to two pressurized sensors. Fourth, a flow rate can be recorded within the pipe by the flow rate indicator. Step 5. Repetition step 1 to 4 is needed for various pipe types, 90 degree, and 45-degree bending piping. And the last step is all data are tabulated and volumetric flow head loss are recorded. So that's all. Let's pass to the next presenter.
Thank you, Sunny. Now I will continue with the result. First, we have to collect the data for volumetric flow and measured head loss for the 4 different type of pipe, which are straight, elbow pipe 90 degree, bend pipe 90 degree, and 45 degree. And then we can calculate the velocity using formula 4Q divided by pi d squared. And after that, we can calculate the Reynolds number using a formula of rho Vd divided by viscosity. And then we calculate the coefficient of friction by using Colebrook equation using the formula shown in the slide. And lastly, we calculate the head loss using the formula of coefficient of friction times Lv squared divided by d2g. Next, we move to the graph. The graph shows a comparison between the measured head loss and calculated head loss versus volumetric flow. As we can see, there is a slight difference between the measured and calculated head loss. The calculated head loss is very consistent, while the measured head loss is not consistent. This is due to the external factor. Next, we move to the discussion. For the first question, explain how the strain gauge sense the pressure. Pressure transducer and pressure sensor frequently use a spring element on which several strain gauges are mounted. As a result, they behave in the same way a force transducer. The diaphragm is commonly used as the pressure-sensitive measuring body in the lower pressure range, while the spring part is frequently a single tubular piece of steel in the higher pressure range. The process strain puts a mechanical load on the spring part, causing it to deform before returning to its original shape. This deformation can be calculated using strain gauge, which can then be analyzed using measurement electronic. Strain gauge should be placed in area of greatest positive and negative strain or stress to achieve the highest possible sensitivity, because the exact strain gradient and strain distribution in the measuring body are established during the pressure transducer design stage. The shape, location, and length of the measuring grid can be optimized. For strain gauge on the measuring body are connected by a Wheatstone bridge. A measuring amplifier provides an excitation voltage to the strain gauge and acquires and processes the output signal from the bridge circuit to make change in strain resistance visible. The resulting measurement signal can be processed by industrial measuring amplifier before being sent to programmable logic controller PLC. Next, we proceed with the second question by Amirul.
Thank you, Alex. So we continue the rest of the session. What will happen to the head lock if the diameter of the pipe is decreased and the length of the pipe is decreased? The pipe size chosen has significant impact on the head failure of the pipeline. The head loss increased rapidly. The pipe diameter decreased. A smaller pump with a lower power requirement may be used due to the lower pipeline head loss. B. If the length of the pipe is decreased, the head loss will be decreased also. What are the two types of energy losses typically associated with pipe flow?
For your experimental result, which one is the most significant loss of heat incurred by the fluid flowing along the pipe? Major and minor losses are the two types of energy losses commonly associated with the fluid flow through a pipe network. Frictional energy loss due to the viscous effect of the medium and the pipe wall roughness causes major losses, while pipe fittings, changes in flow path, and changes in flow field cause minor losses. According to the result of the experiment, major losses are the most significant heat losses experienced by the fluid flowing through the pipe. Significant losses accumulate over the pipeline. Such losses can be reduced to a bare minimum by following best design practices. Minor losses, which are much smaller than major losses, can usually be overlooked if the pipe is not enough. How can you find the values of minor losses coefficient for your experiment? The values of minor losses coefficient for our experiment may be evaluated or occur as a result of a change in path, bend, or other disturbance. Surface roughness will be determined by the pressure loss observed at a given flow rate. To display the pressure reading, the pressure gauge is connected to the pressure tappings in the pipe. To observe head loss in the case of minor losses is due to the object loss plus pipe friction. So in order to determine an appropriate value for lambda, we must refer to your calculation from the major losses section of the experiment. Calculate lambda using the Moody equation or diagram from the K divided by D value and obtain earlier for galvanicity or simply use the value of lambda from the experiment if the velocity in the minor loss experiment is quite close to one of the velocity used in the major loss experiment for 55 millimeter galvanized steel. The head loss coefficient, which is the K, is the only unknown in the equation. Once the value for lambda is determined, as a result, assign a value to each object and compare it to typical value for each device. Next slide. Compare your critical Reynolds number with the theoretical value at which the transition from lamina to the turbulent flow occurs. What are the most significant reasons for the difference between the two? When compared to the theoretical value at which the transition from lamina to turbulent flow occurs, the critical Reynolds number calculated for the data in this experiment is different. The most significant difference between the two is that all the Reynolds number value calculated for the data in this experiment are greater than 3,700, indicating a turbulent flow. So that's all for us. I will invite Azman to continue the presentation.
Thank you, Amirul Hakim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azman bin Muhammad Zaki. My metric ID is MA18245, and now I will continue to present about the conclusion. As a conclusion, we have successfully done the experiment virtually based on the given video and collected data. We have known and understand how to explain the mechanics of fluid friction phenomenon in pipes which is the head loss is a measure of reduction in the total of head of the fluid as it moves through a pipeline, and the head loss along the pipe wall is called friction loss or head loss due to the friction. After that, we also now have understand and can apply the basic knowledge of major losses in straight pipes. The major head loss is roughly proportional to the square of the flow rate in most engineering flows, where it is where the fully developed or turbulent pipe flow. And lastly, based on the experiment data, we concluded that the friction losses are inversely proportional to the Reynolds number. If the length of the pipe is decreased, the head loss will be decreased. The higher the velocity of the fluid will increase, the friction losses in pipe and the increase of the diameter of the pipe will decrease the friction losses. That's all from me. Thank you.